So today we're going to take a look at the first day of Module 6, which is going to cover Pythagorean Theorem as well as geometric mean. And you may remember that we've talked about geometric mean before. We talked about it in Module 5 very briefly, but we're going to give new context to why that's important today. So taking a look at these first two warm-up questions, go ahead and pause the video and try these two questions on your own. If you're stuck, think about what you know about right triangles and what theorem you might be able to use to help you. So my hint would be a squared plus b squared equals c squared might be a good place to start. Once you've tried the first question, you may want to unpause and check your work and then try the second one. So looking at what we've done here, we've identified our c value as our hypotenuse. So you'll notice that that right angle always points to your c value. So x minus 1 squared plus x plus 6 squared should equal 13 squared. Be careful when you square this binomial right here. Notice that we rewrote that as x minus 1 times x minus 1, and then we cleaned up from there. So once you get to this point, every term that you have here, we have a quadratic, we have an x term, and we have a constant term, and they're all divisible by 2. So we divided everything by 2 to make our life a little easier, and then we factored that quadratic. There came out to be two answers, negative 11 or positive 6. However, if you plug in negative 11 to either of these two distances, we're going to end up with a negative distance, which we can't have in geometry. So x equals 6 is our only valid answer. Very similar process for the question number 2. We've distributed, we've combined like terms, and then same thing here, all of these are divisible by 10. So we've divided that out, we factored to find that either x is 7 or negative 5. If I plug in negative 5 here, that gives me a 0 distance, which doesn't make sense for the context of the problem. So x equals 7 is our only valid answer. Now we've seen the first part of this lesson, the Pythagorean theorem, we've seen that before. So my hope is that this was a question that even if you might have gotten stuck a little bit, now that you've seen how to work that, you kind of understand that process. But we are going to do a couple of Pythagorean theorem questions together, and then you can move forward to the final section of the notes for today. So our two goals are to apply Pythagorean theorem and use similar right triangles in the context of geometric mean. So Pythagorean theorem says if we have a right triangle, then the two legs added together once they're squared will equal the hypotenuse squared. So a squared plus b squared equals c squared. Now you'll notice that we've written this backwards from how we normally write that. And there's going to be a purpose for that here in just a little bit. But in terms of your notes, I might jot down that a right triangle will always have c squared equal to a squared plus b squared. In the context of this question, remember that c represents your hypotenuse. And c will always be your biggest number because your hypotenuse will always be your longest side. So we're going to use the Pythagorean theorem in the context of a couple of word problems here. So it says the top of the ladder rests against a wall. So we may want to get ourselves a picture. We've got this wall. We've got this ladder. I'm not a great artist, so we're just kind of going to sketch this here. But it says that it reaches the wall 23 feet above the ground. So I know that this is 23 feet high where it's touching the wall. The base of the ladder is 6 feet away from the wall. And we want to know what is the length of the ladder. So in this case, because we have a vertical meeting a horizontal, we know that there's a 90-degree angle there. And therefore, a squared plus b squared should equal c squared. From here, 23 squared is going to give me 529. 6 squared is going to give me 36, so if I add them together, I get 565 equals c squared. Now for the purposes of this test, a lot of our answers are going to be left in simplest radical form. However, in this particular question, they don't ask us to write our answer in any particular format. So what I'm going to do is I'm just going to go ahead and take a square root of both sides and say C is approximately 23.8, which means that this ladder is approximately 23.8 feet long. The next one says, find the area of an isosceles triangle. So let's sketch our picture here. We've got an isosceles triangle with side lengths of 10, 13, and 13. And thinking about what I know about the area of a triangle, my formula is supposed to be 1/2 base times height. So looking at the info that I currently have, I have the base, so I can go ahead and substitute that in, but I don't know how tall this is. So what I'm going to do is I'm going to drop a height through the middle of the figure here. And since this is isosceles, what this is going to do is it's going to split my base into 2 equal chunks, 5 and 5. And that's going to create now for me a right triangle where I have 5 as one of the legs, an unknown height as the other leg, and 13 as my hypotenuse. So I can set up a squared plus b squared equals c squared. 13 squared is going to give me 169. 5 squared is going to give me 25. So if I subtract that, h squared equals 144. The square root of 144 is 12. So my height is 12 meters. Then at that point, half of 10 times 12 is going to give me 60 square meters for the area of this triangle. Now notice when we did find the area of the whole thing, our base was the entire original base. It was that 10 that we had, but our vertical height we solved by dropping what we call an altitude or a height inside of that triangle, splitting the base, and using Pythagorean theorem. So what we just discovered are whole numbers that will always work for the Pythagorean theorem. So looking back here, we had 5, 12, and 13 as the 3 side lengths of this triangle. So that's what we refer to as a Pythagorean triple, meaning any multiple of those numbers will work for Pythagorean theorem. You may remember earlier in the semester we've talked about a 3, 4, 5 triangle as a common triple that we see on the ACT. So that is definitely one that you want to keep in mind. The last 2 listed here are not as common, but you do see them from time to time. And these just help save you a little bit of time on those timed tests. So looking at what we have here, if I notice, this first question is just 3 times 3. This next one is 4 times 3. So since this is a right triangle, this is a 3, 4, 5. So 5 times 3 would give me my hypotenuse. And I can jump to the fact that that is 15 without wasting a lot of time. Now, if I didn't notice that this is a 3, 4, 5, I could have also said 9 squared plus 12 squared equals x squared and solved, and I'll still end up with 15, but this method just saves me a little bit of time. So glancing up here, same thing. This is a 5 times 2 and a 12 times 2, so this will be 13 times 2, or 26. For the next few pieces here, we can again look for those triples, or if we don't see one right off the bat, 48 squared plus 14 squared equals x squared. Remember that hypotenuse is always your c value, and this 90-degree angle box will always point to that c value. So 48 squared plus 14 squared, that's going to give me 2,500. And if I take the square root of that, I end up with x equals 50. So this would have been one of my triples, so I might have noticed what that triple actually was. But if I don't, totally okay. I can go through that process. Either way will work. So this is something that is commonly forgotten for this test, so you may want to put a star by this in your notes as something to look back on. And it says the triangle inequality theorem tells us that the sum of the lengths of any two sides of a triangle must be greater than the third side. So in other words, any two sides added, any combination, if I add, let's say A and B, they have to be greater than C. If I add B and C, they have to be greater than A. And if I add A and C, they have to be greater than B. So any combination of two sides has to be bigger than the third. If not, we end up with one really long side that we can never form into a triangle. So we might have a teeny side here, and a really, really long side. Those are never going to connect, right? There's no way to get this point to join with that one. So because of that, the triangle inequality theorem says any two sides added together has to be bigger than the third. This is the important part here in terms of new information with the Pythagorean theorem. So I would jot down this part right here. If c squared, or if your biggest number squared, is less than the sum of the other two squared and added together, then this triangle is an acute triangle. If c squared is greater than the sum of the other two sides squared, then it is obtuse. So again, we've already said if c squared equals a squared plus b squared, that is a right triangle. Now we're saying if c squared is less, it's acute, and if c squared is bigger, it's obtuse. Again, this is a commonly forgotten test item, so you may want to put a star by this question. So it says, can the segments 4.3, 5.2, and 6.1 form a triangle? If so, is it acute, right, or obtuse? So what I want to look at is 4 plus 3 plus 5.2 greater than 6.1? Yes. Is 5.2 plus 6.1 greater than 4.3? Yes. And is 6.1 plus 4.3 greater than 5.2? Yes, it is. So using the triangle inequality theorem, yes, this is a triangle. So now let's find out which kind. So remember, c is always your biggest number. So we're going to say 6.1 squared. How does that relate to 4.3 squared plus 5.2 squared? So looking at that on the right side, I end up with 5.53, or 45 and 53 hundredths. And if I square 6.1, I end up with 37 and 21 hundredths. And then I want to decide, is this less than, greater than, or equal to? And this is a less than scenario, which tells me this is an acute triangle. Now I would recommend that you try the next one on your own. Determine, is this acute, right, or obtuse? This one can be a triangle using the triangle inequality theorem. Again, remember, you always start with your biggest number. How does 6 squared relate to 3 squared plus 4 squared? So how does 36 relate to 9 plus 16? That is a greater than situation. So this is an obtuse triangle. If we have these 3 points on a graph, we want to first plot the points, look at the triangle, and then assess what does this look like it is. So for the first one, -2, 4, 6, 0, and -5, -2. So if I look at this, to me, it looks like that's an obtuse angle at the top, but it might be a right angle. To test if it's a right angle, I could just look at the slope or the rise over run. So we rise 1, 2, 3, 4, 5, 6. Run 1, 2, 3, 4. So 6 over 4 is our slope, or 3/2. Then for this side, we've got down 1, 2, 3, 4. Right 1, 2, 3, 4, 5, 6, 7, 8. So -3 over 8, that's not a right angle. So I can rule out that this is not a right triangle because my slopes are not opposite reciprocal. So with that, now I would need to find the length of this side, the length of this side, the length of this side, and then use that c squared is less than, equal to, or greater than a squared plus b squared. For sake of time today, I'm going to go ahead and move forward. But remember that if you don't want to use the distance formula, you can always set up a right triangle and use Pythagorean theorem to find that missing side length. So for the next part here, we have if the altitude is drawn from a right angle to the opposite side, what happens is we have 3 similar triangles that are formed. So in other words, if we drop an altitude from a 90-degree angle so that it's perpendicular to the other side, the smallest triangle there on the right is similar to the one on the left, which is also similar to the entire original triangle. So what they've done for you here is they've redrawn the 2 triangles on the left and the right. So they've redrawn them here in red and here in blue. And then they've turned them so that they're all in corresponding locations. And what happens is that all 3 of these triangles are similar to each other, which means they're proportional in terms of their side lengths. So in other words, CD over AD would equal DB over DC, or any other combination of proportions I would like to make will be true. Now there's also a way that you can memorize how to do this using these 2 sayings right here. So I'm going to show you how to do this using similar triangles, and then I'm going to show you how to do this using the 2 shortcuts. So if I look at this, if I want to find x, and I look at this triangle on the left, I have 3 sides for that triangle, 4, x, and z. And notice I said those in order from the smallest side to the largest side. So 4, x, and z, smallest to largest. And then if I look at this triangle on the right, I have x, 9, and y as my 3 sides, again, from smallest to largest. And because of the way I've said this, they should all be proportional. Smallest over smallest equals medium over medium equals large over large. Now if you notice, that final ratio has 2 variables in it. So essentially what I'm going to do is I'm going to ignore it. And I'm going to focus my attention for those first 2 ratios. And now that I have them set up as a proportion, I can cross multiply. Take my square root of both sides, so x is 6. Now remember, whenever we take a square root, we should put plus or minus in front of that number, right? Because positive 6 or negative 6. However, in geometry, if we're looking for a distance, the only thing that matters is that positive value. So in this case, x can only be 6. Then I have 2 other variables. So I'm going to make a note that I know now that this is 6, and I'm going to go back and look at that picture. So now, if I look at these, for the triangle on the left, I have 4, 6, and z, again from least to greatest. And for the triangle on the right, I have 6, 9, and y. Again, since these are all equivalent ratios, I can set them equal. And this time, I really just have more information than I need, right? The first two ratios are both going to simplify to 2/3. So if I wanted to, I could rewrite that as 2/3 equals z over y. And I'm going to cross multiply. When I do that, though, I'm going to end up with two variables, right? So in this case, there's just not enough information. But remember that all three of these triangles are similar. So let's double back. I also know within the smallest triangle, if I list them from smallest to greatest, 4, 6, and z, and this time I'm going to need to look at the entire triangle. So in this case, I have z, y, and notice this whole side is added together, which will be 13. Set them all up as equivalent proportions, and then we can figure out which one of these do we want to ignore. Well, I noticed that this guy here in the middle is the only thing that talks about y, so I'm essentially going to ignore that. And I'm just going to look at 4 over z equals z over 13. And I'm going to cross multiply from here. So 4 times 13 is going to give me 52 equals z squared. And then I'm going to take the square root of 52. From there, what I want to test is there any perfect square that divides into 52 so that I can simplify this square root? So, with 52, I know that 49 is the next lowest perfect square, and that is not going to divide into 52. 36 is not going to divide into 52. 25 is not going to divide into 52. 16 is not going to divide into 52. Neither is 9, and neither is, oh, there it is. It's going to be divisible by 4. And at this point, my square root of 4 becomes 2. So I'm going to scoot this down just a little bit here. So I've got the square root of 4, square root of 13. Square root of 4 is 2. So 2 square roots of 13 is my z value. Last but not least, we need to find our y value. So now that I know that this is 2 square roots of 13, I would really like to avoid dealing with that square root if I can. So I'm going to see if there's any other way that I can set up and solve for y. So looking at the information that I have, I'm looking for the hypotenuse. So if I want to look at the red triangle from least to greatest, 6, 9, and y, and if I want to look at the green triangle from least to greatest, I end up here. And I can set all of these equal to each other. And because this one has kind of the ugliness, I'm going to ignore that, and I'm going to only focus on the two on the right. So kind of like we did here where we ignored this guy, we're now going to ignore this one. So that we have 9 times 13 equals y squared. I'm going to take a square root of both sides. I know that 9 is the greatest perfect square that divides into 117. Break that up. Square root of 9 is 3. So 3 square roots of 13 is my y value. Now, for what we just did, this process will work every time. However, for some of you guys, finding the smallest, the medium, and the large gets a little bit difficult sometimes. So I'm going to give you another option. Option 2 is that we memorize these two phrases, which are altitude splits and legs round. So if we go back to what information we had from the beginning, the altitude is what drops down vertically. Okay, it's your height of that triangle. So the altitude splits rule says that the altitude will always equal whatever the number is on the left times the number on the right. So in other words, in this case, x will equal the square root of 4 times 9. And I'm going to rewrite that with that 4 first. Your left and right really don't matter because you're going to multiply them. But 4 times 9 is 36, and the square root of 36 is 6. Now, arguably, that's way faster, right? However, what you have to recognize is that you're now committing to memorizing this rule. So you want to make sure that you not only know this rule, but you know how to use it. So again, altitude splits says that the altitude will always equal the square root of the number on the left times the number on the right. Kind of creates that curly Q mustache. Oops. Then, our other phrase, if we want to memorize it instead of doing that small, medium, large thing, is called legs round. And legs round says whichever of the two legs of this right triangle that you're looking for will always have a pattern that says the leg equals the square root of the first number that you hit as you round the corner, right? Legs round times the total of the hypotenuse. So in this case, if I'm looking for z, it's the square root of 4 times the total of this side, so times 13. Or if you were looking for y, notice that our first, right, we're rounding toward the hypotenuse. Our first number is 9 times our total, which is 13. Again, guys, it's up to you if you want to memorize these phrases, these sayings, or if you want to use the similar triangles. Either option is valid. It just depends on, do you prefer to memorize something extra or not. So let's put these into use, and I'm going to kind of show you using the shortcuts or the rules, if you will. So with this one, I could use my altitude splits because I've got the altitude here labeled. That's what tells me that I'm probably going to need that information. Notice there's nothing provided on this leg or this leg of that largest right triangle, so I can't use legs round. So remember, the altitude equals the square root of the number on the left times the number on the right. So 18 equals the square root of 12 times y. To get rid of a square root, we square both sides. So 18 squared is 324. When I square this side, I get rid of that square root. And then I divide by 12 to find that y is 27. If I wanted to use the similar triangles, I could have also said smaller leg, bigger leg for this triangle here is proportional to the smaller leg, bigger leg of this triangle. Set those ratios equal to each other and cross multiply. Either way, you should come up with the same answer, that y is 27. For the next one, I notice that there's no marking whatsoever for the altitude. So I can't use the altitude splits rule. So I can either use the legs round rule, or I can use my similar triangles. So the legs round rule says the leg equals the square root of the first number we hit when we round the corner to the hypotenuse times the total. So in this case, the legs are referring to the two sides surrounding that 90-degree angle. So 27 is the leg, should equal, as we round the corner, remember we're going to the hypotenuse as quick as we can, we've got 16, and our total is z. Similar process here, we're going to square both sides, and then divide by 16 to find out that z is 45.5625, but I'm just going to round that here. I'm going to approximate that and say 45.6. If we wanted to use similar triangles, we've got the smaller triangle here where we have the smallest side, we don't know the medium, and we have the largest. Then looking at the larger triangle, looking at everything put together, my smallest side is 27. I don't know my medium size, and z is the one that we're missing. So set up my ratios. Ignore the one in the middle where we don't have enough info, and we can cross multiply. Either way, we should end up with the same answer. For this next question, if we know that we have x as one of the two legs of this right triangle, we can use legs round again. So it's the first number you hit as you round to the hypotenuse times the total. I misspelled total really badly there, so pretend that says total. So as we round the corner from x, the first number we hit is 5, and the total are those two added together, so 5 times 9. And instead of going ahead and multiplying those, I recognize that 9 is a perfect square, so this is going to become 3 square roots of 5. If we wanted to use similar triangles, looking at this smaller triangle here, it's hard to tell which is the smaller and which is the longer of the two legs. So this is where it gets a little bit tricky not to know those rules. However, it looks like we have the longer side. So I'm going to say we don't know. We have 5, and we have x as the hypotenuse. And then looking at the entire triangle, again, we don't know the smaller. We have x for the medium, and we have 9. So in this case, we ignore the first one where we don't have enough information, and we can cross multiply to find x. Either way should get you the same answer. Here's a couple of other examples. I would recommend that you kind of try these on your own, think through these processes, and then come back to check in. This first one here, we can either use the altitude splits rule. Again, the reason we know that is because the altitude is labeled with information that we need to use, which says take the square root of the number on the left times the number on the right. In this case, it's flipped upside down, but remember, left and right really don't matter because you're multiplying them. So 6 should equal the square root of 8 times b plus 3. I'm going to go ahead and square both sides to get rid of that square root. So 36 equals 8 times b plus 3. Then I'm going to distribute and solve just like I normally would. So 36 minus 24 gives me 12. And then 12 divided by 8 is going to give me a fraction or a decimal. So b is 1 1/2, or 1.5. If you wanted to use your similar triangles, we could set up small over long equals small over long. We'll still end up there. Looking at the triangle on the right, you now have 3 missing pieces. I notice that the altitude is labeled, so I might start with that altitude splits rule, which says the left times the right. So x times 16. The altitude itself is labeled as 12. To get rid of my square root, we square both sides. And then we divide by 16 to get our final answer, which is x equals 9. We still need to find y and z. Y and z are the 2 legs of this right triangle, so I'm going to use the legs round rule, which says it equals the square root of the first number you hit as you round to the hypotenuse times the total. And you want to be really careful here. If we start with z, when I round the corner I hit 16, and the total is 16 and x added together. But remember, that's not 16x. I also notice that I now have 2 components that are unknown. However, the x value I just found to be 9. So really, I could go back and I could say my total is whatever 16 plus 9 is, because I've already figured out that my x is 9. So by adding those together, my total is 25. The square root of 16 is 4, the square root of 25 is 5, and 4 times 5 is 20. So my z value comes out to be 20. My y value is another leg of that triangle. So same process, first times total. So y equals the square root of 9 times the total of that side, which is 25. Square root of 9 is 3. Square root of 25 is 5. 3 times 5 is 15. Again, guys, you can use your similar triangles. So if you wanted to solve each of these using similar triangles, you can do that by setting up small, medium, large over small, medium, large and solving for each of these variables. It's entirely up to you which process you prefer. Final few questions here. Determine if these are a right triangle. If so, find the length of the altitude to the hypotenuse. Round your decimals to the nearest tenth. So if this is a right triangle, that 2 square roots of 89, that ends up being approximately 18.9. So this is the biggest side. So I'm going to test, is a squared plus b squared equal to c squared? Now be careful here. The left side should be pretty easy to just type into your calculator. The right side, however, be careful. You're squaring the 2 and you're squaring the square root of 89. So that 4 times 89 is 356. So since they're equal, we're going to say yes, this is a right triangle. Now for the purposes of what I would like for you guys to do, for right now, all we're going to do is determine if this is a right triangle or not. For the one on the right, that 4 square roots of 13, that comes out to be about 14.4, so that's our biggest number. So that would be our c value. So we want to see, is 8 squared plus 12 squared truly equal to 4 square roots of 13 squared? So remember, on the right side, you're going to square the 4 and square that square root. So on the right side, we have 208. And I want to know, is that equal to 8 squared plus 12 squared, which is 208? So since they are equal, yes, this is a right triangle. At this point, you may move on to the practice. Have a great day.